Hello children, today we shall see the last part of this chapter, chemical reactions. So in our last class we have seen types of chemical reaction. Further to it we are going to see the energy changes in chemical reactions and reactions based on energy change. First let's recap what we've seen in our last video. We've seen the types of chemical reactions. So in that the first type was direct combination, that is also called as synthesis, where two or more elements or compounds combine to give us one product. So when we have more than one element or compound combining to give just one product is called as direct combination reaction. Then we saw decomposition reaction. Decomposition reaction is just the opposite of direct combination reaction. Here from one compound we can get two or more simpler substances. Displacement reaction. In displacement reaction we have single displacement where a more reactive element is capable of displacing a lesser reactive element from another compound. And double decomposition reaction. So double decomposition reaction where two compounds react with each other to exchange their positive and negative ions. So in detail if you would see this, direct combination reaction and decomposition reaction. Direct combination has only one type of reaction, that's just synthesis reaction, but in decomposition we have seen electrolysis, photolysis and thermal decomposition. Electrolysis is a decomposition reaction where electricity is required. Photolysis is a decomposition reaction where light energy is required, and thermal decomposition requires heat energy. For single displacement it is very important for us to note the metal activity series or the reactivity of various elements. So here once again I'd like to stress on this point. We need to know the metal activity series very well. So for metals it is potassium, sodium, calcium, then magnesium, followed with aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold and then platinum. So the most reactive metal is potassium and the least reactive metal is platinum. So as per this series only, the element higher in the activity series can displace an element which is lower in the activity series. The displacement reaction will not take place from a lower activity element replacing an element higher in the activity series. So similarly for nonmetals, fluorine is the most active nonmetal, followed by chlorine, then it is bromine and iodine. So it is very important to note that more reactive an element is, it is able to displace the lesser reactive element from its solution, from its salt solution or from its compound. So the last type of reaction was double decomposition reaction, and in this reaction we saw neutralization reactions. Neutralizations are acid-base reaction where acid reacts with base to give us salt and water. And the last precipitation reaction is a formation of precipitate, that's an insoluble solid in an aqueous solution. Formation of precipitate in an aqueous solution. These are types of double decomposition reaction. Today we shall see the energy change in chemical reaction. So we are going to see the energy changes in chemical reactions and which are the types of reactions based on these energy changes. So in every chemical reaction, change in energy is involved. So whenever a chemical reaction takes place, some kind of change in energy is definitely involved in that. There is a difference between the chemical energies of the reactants and the products. So generally, whatever energy level is there of a reactant will be different from that of the products. This energy can be in the form of heat, light, sound and electricity. This energy could be in the form of heat, light, sound and even electricity. every substance has a fixed amount of stored energy, which is in the form of potential energy and is referred to as chemical energy. So every substance has some energy inside it. Any matter has energy inside it. This is called its potential energy. So whenever a chemical reaction takes place, it involves what? Breaking up of chemical bonds between the atom, which can result in absorption of energy in the form of heat. At the same time, formation of bonds with release of energy. These two types of energies are different from each other. So there is either extra surplus energy or sometimes there is lesser energy during the reaction. Therefore, a chemical reaction, whenever it takes place, either energy is absorbed or it is released. Now, based on the fact whether the energy is absorbed or released, we have two types of chemical reactions, and they are, the first one is exothermic reaction. So by the name itself, exothermic means something that gives out. Exo gives out, thermic heat. So it gives out heat. So the reaction in which is accompanied by evolution of heat is known as exothermic reaction. The reaction in which heat is given out. In simple words, whenever heat is given out in a reaction, it is called as exothermic reaction. It is because of this heat given out in the reaction, it causes a rise in the temperature of the surrounding. Now, since in exothermic reaction heat is given out, naturally it rises the temperature of the surrounding. So suppose a reaction is taking place in the test tube, you will find that the walls of the test tube are heated up, or is warmer, or the temperature is rising in that. The total energy content of the reactants is more than that of the product. So whatever energy was there in the reactants, the total energy of the reactants, that is more than that of the products, and hence extra energy is given out. So exothermic reaction, let's see some examples. Exothermic means they are going to give out heat, light, energy. So naturally there will be some kind of combustion reactions. So burning of coal, petrol, kerosene, cooking gas, etc. These are all exothermic reactions. So whenever we see there is a heat and light given out, that kind of a reaction will be an exothermic reaction. Let's see one example. When coal is burnt in oxygen, so combustion of coal, C plus O2 gives us carbon dioxide and heat. So heat is released in this chemical change, or in this chemical reaction. So that's why we call it a exothermic reaction. Let's see one more example. Where calcium oxide reacts with water. Calcium oxide is also called as quicklime. When quicklime reacts with water, like tuna, what we say, it gives us calcium hydroxide. Calcium hydroxide is called slaked lime. So slaked lime plus heat is given out. So whenever we add quicklime into water, we notice that this whole solution, it heats up. Why it heats up? It heats up because it's an exothermic reaction. Now let's see the next type of reaction, that is endothermic reaction. So by the name itself, endothermic means it ends heat. So in this reaction, the reaction is accompanied by absorption of heat. So to end heat, the heat is being absorbed in the reaction itself. So a reaction accompanied by absorption of heat is known as endothermic reaction. It causes a fall in the temperature of the surrounding. The temperatures of the surrounding drop. So if you're having a test tube in which you're conducting an endothermic reaction, the walls of the test tubes will get cool. And why it will get cool? Because the heat is given, or heat is absorbed during the reaction time. Endothermic reactions cannot sustain without supply of energy from external source. So for endothermic reactions to take place, we have to provide energy from an external source. It generally requires heat for an endothermic reaction to take place. The total energy content of the products is more than that of the reactant. So the energy content of the products here is more than that of the reactants. So since the energy of the products is more, so hence it will absorb the heat. It will absorb the heat. So let's see some examples of endothermic reactions. Melting of ice is an endothermic reaction. So when ice melts, what happens? It is absorbing heat from the surroundings. So naturally it is causing a cooling effect. Let's see the chemical equation here. If carbon, which is solid in nature, is treated with sulfur, which is also solid in nature, okay, and you have to heat this. If carbon plus sulfur is heated, both are in solid form, we get a compound called as carbon disulfide, which is a liquid. So the temperature of carbon disulfide will be lower than that of the reactants. Let's take one more example where calcium carbonate is heated. So it is also called as a thermal decomposition of calcium carbonate. So whenever we have these thermal decomposition reactions, they will be endothermic reactions because heat energy is required to decompose substances or to decompose compounds. So calcium carbonate, when it is heated, we get calcium oxide and carbon dioxide. So heat is required when the calcium carbonate has to react to split up. So naturally it causes a cooling effect, and such a kind of a reaction is called as a endothermic reaction because heat is required for breaking the bonds between calcium and carbonate. So more heat is required there. So hence the resultant products have a lower temperature. Now let's see two other types of reactions that we have in this chapter. One is the photochemical reaction. We have already seen photolysis. So photolysis is a reaction where in the presence of light energy, a decomposition takes place. But the difference between a photochemical reaction and a photolysis reaction is this could be any chemical reaction. It need not be a decomposition reaction. So a reaction which occurs with the absorption of light energy. So whenever light energy is required in a particular reaction, it is called as a photochemical reaction. The most common example of it is photosynthesis. Plants undergo photosynthesis where carbon dioxide and water in presence of sunlight are converted to glucose, water and oxygen. So this reaction, photosynthesis, is an example of a photochemical reaction, and we also have all the decomposition reactions, photolysis reactions, which are also called as photochemical reactions. So we see the same example here. Silver chloride or silver nitrate in presence of sunlight or light can decompose to give us silver and corresponding compounds. In this reaction, we are getting silver and chlorine gas. Electrochemical reactions. Electrochemical reaction is a reaction that occurs with the absorption of electrical energy. So whenever electrical energy is absorbed or is an important part of the reaction is required for the reaction to take place, such a reaction is called as a electrochemical reaction. So they may be decomposition reactions or otherwise. So in this case, we see the decomposition of water with the help of electricity. So it's also called as an electrolysis reaction or a electrochemical reaction. So with this, we have completed this second chapter